All right, everybody, I think we're going to get started. Good morning. Welcome to the second day of Mobiconf. Today we're going to be talking about the evolution of asynchronous programming on iOS. And before we get started, I want to tell you a little story about how I really messed up asynchronous programming. I was first learning iOS late 2009, early 2010. I tried doing asynchronous programming with NS Operation, which at the time was a lot more difficult than it is now. And then WWDC 2010 blocks and Grand Central Dispatch came out for iOS, which was really exciting. And I figured that this was the way to do asynchronous programming, blocks, GCD. So I got my first full-time iOS job shortly after that, and when it came to do the asynchronous part of the application, I figured blocks. That's what I'll do. I went overboard. I used blocks everywhere. It was not a good code base. And the last time I checked, the developers still at the company are still dealing with my mess. So keep that in mind as we go forward and talk about some of the history of asynchronous programming and also like what we're going to be doing in the future. So the evolution of asynchronous programming. Today we're going to take a look at the evolution on iOS. And it's a good question to ask why we're doing this. I mean, why are you all here? The reason I have is because I believe that the past and what worked or didn't work in the past can actually influence how we make decisions today. And by learning from the past, we can make better decisions about the present and in the future. So asynchronous programming, what is that even? I mean, it's a pretty broad topic. Basically, it means that you want to do a thing later, or maybe you want to do a thing and then when it's done, you want this other thing to happen. Asynchronous programming is basically anything that doesn't happen immediately. So the agenda we're going to talk about first, we're going to talk about context and how every decision is made in one. Then we're going to talk about how iOS developers are human, contrary to what some of the Android developers may say. We're going to look at the older solutions and how they have value as well. And finally, we're going to look at the benefits generally of using older technology. So decisions are made in a context. This is really important to keep in mind when you look at history in general, but also history of iOS development. It's really important to understand that every decision made ever, especially in iOS, is made in a context. So what's a context? Generally speaking, a context is the space and time that a decision was made in. There are some questions that you can ask yourself in order to figure out the context when you're currently making a decision. That can be what technology is available? How familiar am I with that technology? How familiar is my team with the technology? Is it popular? Is it going to get popular, or is it declining in popularity? How stable are the tools? This was a really big contextual question when Swift came out because the tools were not that stable. How easy is this technology to learn? That goes hand in hand with how familiar it is. And how quickly do I need to complete the task or the project or whatever it is that I'm using the technology for? The general point I'm trying to make is that decisions aren't made in a vacuum. The decision to use Swift or Objective-C or anything isn't made by itself. There's always factors that enter into the decision-making process. There's always a context. And it's really important to understand that the person who made the decision, at the time they made it, the decision made sense, probably. I mean, most people don't make decisions because they figure, this is a bad idea, I'll do it. I mean, most people just don't do that, right? So it's really important to not forget that contexts exist in every decision. And they're unique in space and time. You can't really recover a context. You can't think about something later and try and remember what your context was when you made that decision. You're going to forget. Your experience since you made the decision is going to influence your memory. Documentation is never 100% complete. It can't accurately convey the entire range of what you were thinking and feeling when you made that decision. If you've ever written code at night or on a Friday before weekend, and you came back to it the next day, and you had no idea what was going on, You didn't know what the code was doing, what it was supposed to do. You didn't understand how it ever worked at all. That's because you no longer had the context that you had when you wrote that code. The context is gone forever. So this leads us to adopting a code base. This is a really disorienting experience. If you've ever come into an existing project, maybe the developer's there, maybe they're not. Either way, it can be very uncomfortable to do. And the biggest reason is because you don't have any context. You are completely outside of your element. You've got no idea what's going on, or the things that influence the decisions that led to the code base. You don't have any of that context. Why would someone do something this way? Even if it's documented, which, let's be honest, it probably isn't documented that well, it's still not sufficient. Context includes the experience that you have and the experience that your team has. It's not just the experience you have now, it's the experience you intend to get down the road if you're going to expand your team, or if you're going to learn a new technology, if you're planning on switching from Objective-C to React Native, all kinds of things. And nobody gets it right on the first try. I mean, I was talking earlier today with someone, and we just discussed how the way to learn something is to make mistakes. I mean, that's how we learn. And you can't blame yourself or anyone else for making a mistake. The context includes I'm a beginner. So you can never understand the context in which a decision was made. But you don't really have to. It is enough to know that a context existed. You don't actually have to know what the context was. And this is a really, really interesting point, I think. As long as you appreciate that there was a context and that the decisions that you see, maybe you disagree with, but the decisions made sense at the time, that they made sense to someone, that can lead you to approach coding differently. It can lead you to approach older code that you wrote or someone else wrote differently. Basically what I'm trying to say is be empathetic. I don't want you to be hard on yourself or hard on other people. Don't get angry. It's really counterproductive. I spent a few years of my career being really angry at a lot of different things, especially code, and it got me nowhere. Instead, try and figure out the context. Try and learn about why those decisions made sense to the people at the time. What has changed since then? If you were that person now, would you make the same decision? Do you think that they would? Those are really interesting questions to ask. Remember, nobody gets it right 100% of the time, so mistakes do happen. So don't be hard on yourself. Go easier on your old code, go easier on other people and yourself. Okay, the feelings are mostly over. Let's talk about conflating things. Conflate is a really beautiful word that I love, but it's not a very common word, so I'm going to define it. It's combine two or more ideas into one. This is conflation. Usually it has a negative connotation. So usually when you conflate something, it's bad. And today it's bad. We, as a species, have conflated things for thousands of years. If we saw a comet in the sky and then we stubbed our toe, we would conflate those two things. We would think that the comet and our stubbed toe were connected somehow. Or if there was an earthquake and then a drought, we would connect those two things even though they're not connected at all. Humans look for patterns. We are pattern recognizing machines. We have our brains support advanced hardware with purpose-built, specific built into our chips, like the new M7 or whatever it is in the iPhone. Pattern recognition requires no extra power. It's something that our brains are just doing all the time. We don't even know it. We recognize patterns without trying to. For example, this woman thinks that she found Jesus in her sandwich. I don't know if God uses a sandwich-based communication protocol. I don't know what the latency on that protocol would be. I hope it's encrypted, but I'm not sure. Another example, Donald Trump looks like a tub of margarine, which, I look at that, like the toast thing, whatever. This, yeah, that's definitely Donald Trump. This is something that humans do. Uh, so, he doesn't actually look like a tub of margarine, but we think he does. We see the pattern. What does this have to do with iOS development? Well, I mean, humans conflate things like Donald Trump and margarine, but iOS developers do it a lot. Uh, for example, I see this pattern in our community all the time. There's some popular practice. I mean, it could be anything. It could be the way you write for loops, or it could be the way you space your code, or insert new lines before or after an opening brace bracket. So there's something popular. And then someone's learning iOS for the first time, and they're bad at that popular thing. I mean, that's normal because we're bad at everything when we're learning. That's totally natural. But they conflate that with, they're bad at the popular practice, so that popular practice must be bad. There's a flip side of this. You get better at iOS development. A new thing comes out, and because you're better at development, you're better at the new thing too. So the new thing must be good. I was learning about NS operation before I wrote that application that people are still dealing with. It was hard, I was bad at it. Blocks came out, they seemed cool, and I gotten better at iOS since then, so blocks seemed good too. I was so excited that I decided that blocks were a better way to do asynchronous programming than NS operations. The thing is, blocks are only better than how I was doing NS operation. They weren't better than NS operation altogether. This is why new things are so appealing, because they offer this way for us to take our frustration and the reason why we were bad at something and put it on something else. We don't have to blame ourselves and say, I was bad at NS operations, so I'm going to be easy on it. You don't have to recognize that you made a mistake or I made a mistake. You can put it on something else. This is the cult of the new, and it's really, really popular in iOS. So that leads us to the question, why? Why do iOS developers do this? And there are a few explanations that I'm going to go over. iOS is young. I mean, like, in terms of programming communities, it's one of the younger ones. But it quickly became popular, very quickly. The iPhone launched a year later. We've got the App Store. All of a sudden, people are writing apps for the first time. There were a lot of beginners because there weren't many people who had experience with Objective-C. And there were only a handful of people who had experience with iOS in general, and they mostly worked at Apple. Many beginners, including myself, were younger developers and less experienced. I think that's still pretty true. Like, we have a large proportion of our community are developers who have only done iOS, who came directly into this from school or college, and they didn't have the experience from other communities to bring with them. I'm not judging us. I include myself in that group, but I want to recognize the fact, and I think that we can do that. I think that we're mature enough to do that. Another reason why iOS developers conflate things is that iOS is constantly changing. I mean, like, all the time. There is always an older API that you can blame. You can always blame iOS 8. Last year, we were blaming iOS 7. The year before that was iOS 6. This happens every year. Objective-C is this weird old language with weird syntax. It made sense for us to blame it and move to Swift. Apple started improving Objective-C because it got popular, and some improvements to the language, like arc or automatically synthesized properties, generally those are really good improvements. There isn't a reason not to use arc, in my opinion. But other improvements, like blocks, those aren't always a good idea. You shouldn't always use blocks. They're a really good tool and you should be familiar with them, but you shouldn't use them all the time. We've conflated the new tools that were universally better, like Arc, with the new tools that were better in some cases, like blocks. I've done this a lot, and you probably have too. There are lots of examples from my career. I've started asking myself when I was preparing for this talk a few weeks ago, what sort of judgments did I make about technology that were based on my inexperience at that technology? You know, what came out that was new and I decided to jump on board and say, this is better because I wasn't very good at the old thing. This is okay. It's not a big deal because we're only human. This is something that everyone does. iOS developers tend to do it more than others. That's not a judgment, it's just an observation. Remember, don't be hard on yourself. And most importantly, don't be hard on others. We're all just winging it. I've never been an iOS developer before I was an iOS developer this time. So I'm gonna let myself make a few mistakes. You should too. I mean, let me make mistakes, and also yourself. So this brings us to older solutions. This would have been NS operation in my case. This could be Objective-C. This could be an older version of Xcode or an older programming language that doesn't even do iOS. The older solutions still have merit, and there are good reasons to use them. There's this really common phrase. I couldn't find a source for it. I think it's been said for a long time. Those who don't study history are doomed to repeat it. This is said all the time. Usually the implication is that you should study history or else you're going to repeat the mistakes of the past. This is wrong. I mean, it's not wrong so much as incomplete and wrong. It implies that the past only has mistakes and that there's nothing of value to do there. It says that if you do anything like you did before, then it's bad. It implies that there are no good ideas in history. And I think that it's pretty clear that that's wrong. I think a more accurate phrase would be those who don't study the past can't make informed decisions about the present. This is a less inflammatory phrase, which is why it probably hasn't endured at all. It's not very popular, but I'm trying to make it popular. You know, history has a lot to show us, not just in terms of the mistakes that we shouldn't repeat, but it also shows us the things that we did right that we should do again. So, with that in mind, let's look at the history of asynchronous programming. This is the technical part of the talk. Let's look at perform selector. Perform selector and its associated methods have a really, really bad reputation in the community for, you know, some good reasons and some not good reasons. Multiple arguments with these methods require a lot more work. You have to use NS invocation. Who knows how to do that? I don't. I'd have to look it up on Stack Overflow. That's too much work. But it's really easy for simple invocations. If you have 0 or 1 parameters to a method, you can invoke it with this. You can invoke it on another thread. You can invoke it after a certain delay. It's even sort of cancelable. You know, you can ask the system to cancel perform selector if you invoked it with a delay. And it's sort of thread safe. Nothing is wrong with using perform selector if you know what you're doing. Another really popular one to hate on is NSThread. This was very early in iOS, so this would have been 2 years before blocks and Grand Central Dispatch came out. It's kind of difficult to use, but it has some really easy ways to use it too. There's a family of methods called detach new thread selector to target with object. It seems evil because it returns void, so you can't really cancel it. And it just kind of does its thing on a separate thread, whichever thread you specify, probably the main thread, I mean, let's be honest. But this is really easy for fire and forget methods. If you just need to do something and it doesn't matter if it successfully completes, it doesn't matter when it completes, it doesn't even matter if it completes, this is a good good solution. But more complicated uses of it get more complicated. I looked through some different open source projects looking for the ways that they did asynchronous programming, and Adium uses this, the instant messaging client on OS X. Adium uses NSThread detach new thread selector to target with object. It uses this because it's a convenient way to do something simple. That leads us to NS operation. Again, there at the beginning at IS2, supports concurrency, which is great. I mean, at the time it didn't really matter because you only had one core in your iOS device, but ever since the 4S, we've had multiple cores in their phones at least. So NS operation is pretty great because you can have two things running at the same time. I think it's a bit of a hidden gem. People don't use it enough, in my opinion. There's the support for dependency graphs, which are the coolest thing in the world. I mean, how many times have you had something that needs to happen, but only after this other thing happened? So you need this thing to happen after this one, then this one. You can chain them together with NS operations. You can say that this operation depends on this one being completed first. And it's not just a one-to-one relationship. You can have several of them in a row. You can have, these two operation depends on this one. It's a really powerful way for you to express the asynchronous nature of the code that you're doing in a really safe and expressive way. Because, I mean, I'm not going to be able to understand the block syntax because it's terrible. It's also cancelable. You can cancel an NS operation, which is kind of nice. But the thing is, it requires a little more boilerplate. It takes more typing. Deal with it. This is Objective-C. I mean, come on. You're going to complain about typing something? Xcode has had autocomplete for as long as I've been using it. I think NS operation is a bit like NS string. It does a lot, and you don't really appreciate how much it does until you go to another language or platform that doesn't have it. That brings us to a big jump in asynchronous programming. 2009 with Snow Leopard, and then 2010 with iOS 4, we have Grand Central Dispatch. Ooh, sounds awesome. Everyone's favorite tool is Grand Central Dispatch. It's so easy to use. It's so easy. Dispatch async, dispatch get main queue, and then a little caret and an open thing, and you put your code in there. It happens afterwards sometime. You don't really know when. But it's kind of dangerous because you can have reference cycles super easy. You don't even necessarily recognize it if you're accessing an instance variable on self. You have a reference cycle even though you don't have self inside your block. Swift has made this easier, I guess, but it's still worth considering that this was 4 years before Swift came out. And you cannot cancel a block. Once you dispatch it, that's it. It's gone. As we saw from Junior's talk yesterday, it leads to a callback hell, where you have a dispatch async inside another dispatch async inside another dispatch async. Maybe you're calling a function and it has its own callback hell. It's ridiculous. But iOS 4 had something else that a lot of people didn't really pay any attention to, including me. NS operation and blocks. iOS 4 extended the existing NS operation API to let you create them with blocks. Now you can do everything that NS operation could do and more, which is really great. Less boilerplate. You no longer had to subclass NS operation or do something silly like that. It takes a lot of work. You can create it with a block, and you can have the cancelable property. You can have a lot less boilerplate. You can have dependency chaining, completion handling, so you can say, do this operation, and then when it's done, do this thing. A lot of really cool abstractions. Still a little bit more verbose, but I mean, again, it's Objective-C. Who's going to complain about typing a few more characters? But it's not popular. Why is it not popular? That's a really good question. I think personally it's just because Apple's better at marketing. I mean, I know that's kind of a trope that Windows and Linux and Android people throw at Apple, but it's true. Apple is better at marketing. And they marketed Grand Central Dispatch like crazy. I remember as a user of Leopard, I was upgrading to Snow Leopard, and I was so excited because I got the box in the mail of my operating system. Oh my God, do you remember when you had operating systems shipped to you? It's ridiculous, right? But I remember reading about all the features on Apple's website, and Grand Central Dispatch was one of them. They were marketing this to consumers. That's how excited Apple was about Grand Central Dispatch. And to be fair, GCD is amazing, but it's not the only way to do asynchronous programming. So we waited a few more years, and then iOS 7 came out. And we got this weird class called NSProgress. It's confusing. No one knows what it's for. I don't know. Maybe you know. Anyway, let's skip it. It's been on my to-do list to figure out for years. It does something with asynchronous programming, but no one really knows what it is. NSURL session task. Super cool. This is a network-specific asynchronous way of programming. It doesn't have anything to do with like core data or image processing or audio processing or anything that you might want to do asynchronously or on a background thread. NSURL session isn't really about that. It's just about networking, and it's very nice. It's, I mean, if you were doing NSURL connection, send asynchronous connection before, when NSURL session came out, I was excited, but I didn't use it because no one forced me to, and what I had worked. So I kept on using it, and now it's officially deprecated. So I have to use NSURL session, and it is awesome. We're going to discuss how awesome it is in a little bit. The really important thing to realize is that these are only tools. NS operation, blocks, NS thread, they're just classes. You know, they're not really abstractions. You know, we'd like to build something on top of these tools. So at the bottom, we have function pointers. Then we have blocks on top of those. On top of those, we have NS operation, which wraps a block, I think. And then we have something we can put on top of it. We'd like to code at a higher level of abstraction. I think this is generally true. Developers don't want to be writing assembler. They don't want to be writing, you know, Happy Birds in, you know, x86 assembler or something ridiculous. I mean, we'd like to use object-oriented programming or functional programming or something. So, you know, the idea that we want to use abstraction, great. We use NSString instead of, you know, char arrays. So let's look at some example abstractions. Well, one of the first things to happen when blocks were introduced were that everyone went out and created a library for their favorite UIKit class that they hated. UI gesture recognizer, which also came out in iOS 4, and UI alert view. These were two really popular ones. There are dozens of CocoaPods available for adding completion blocks to these two classes because they were made before blocks were available. I honestly don't think that the people making GCD and the people making UI gesture recognizer talk to each other at all because I think if they had, they would have, you know, used blocks. We also have the idea of futures or promises. I think there's a distinction there, but I don't really care what it is because who cares? But they're cool. I mean, you can say, here's an object, it represents a unit of work, and when it's done, do this thing. If it errors, do this thing. If it you know, returns data, do this other thing. That's a really powerful abstraction because you can chain them. You can say, do this thing, then this thing, then this thing. This is our chaining that we have within NS operation, our dependency graph. On top of that, you have sequences or signals with functional reactive programming. This is my personal favorite because it does everything that futures and promises do and more because you have you know, mapping operations on data flow and you can express things really easily and really succinctly. And those are great abstractions and they all have their place, but I still feel that we ignore NS operation. It's cancelable, you can chain it, you can make dependency graphs. It has concurrency support. I mean, I know that I can do concurrency with RxSwift or Reactive Cocoa, but like, I don't actually know how I would do it off the top of my head anyway. Completion handlers, prioritization. That's so cool. You can say this operation has a higher priority than this one. Very nice. And they interoperate with the GCD. The biggest, maybe the only downside to using NS operation directly is that you have to do more typing. But it's often ignored, even though it's a great solution to a lot of different problems. We ignore it. So, why? Why do we love Grand Central Dispatch so much? I'd love to know. So I thought about it. And it really is, it's just a way it is. I mean, I can't really explain it very well. It doesn't have like a single reason why we favor one over the other. We like GCD over other suitable abstractions. NS operation feels unfamiliar. There's a little bit of not invented here syndrome. I mean, like, GCD feels like an Apple technology. It feels like something that we have that's unique to us. So it makes sense that we would want to use that. And again, Apple is really good at marketing, and they marketed the hell out of Grand Central Dispatch. Yeah. So we have all these tools, but we only really use one of them. GCD is not a universally appropriate solution. There are problems out there where the best solution is not Grand Central Dispatch. Remember my story from the beginning? If I had used NS operation for things like downloading large JPEGs from the internet and possibly wanting to cancel them later, things would have been a lot easier for the team that's still working at the company now. My point is that different solutions work for different problems. This is a pretty simple statement, but it's kind of contentious in developer communities. The idea that there isn't just one way to do something. I mean, that's kind of obvious now that I say it, right? Like if I said there's only one way to paint a painting, or there's only one way to sing a song, that would be ridiculous. But if I say there's only one way to do asynchronous programming, all of a sudden I'm a bad guy. It doesn't make any sense. You should get familiar with the options. We all should. We should learn about the different things that are available to us, because unless we know our options and unless we've experimented with them, we find out what works, what doesn't work, what works better, what works worse. Unless we do that, we can't make an informed decision because we don't know the different options we have to choose from. We need to learn about our different options. We need to learn the contexts that they work well in, and then we need to think about the context that we're making a decision in, and then we can make an informed decision. Don't be mean to other developers just because they disagree with you, because they have a different context than you have, and the decisions that they make sense to them, even though they don't necessarily make sense to you. And don't be mean on yourself either. If you made a decision 6 months or 6 years ago, I don't want you to beat yourself up over it because it made sense at the time. With the knowledge that you had and the context you were in, the decision that you made was a logical, rational decision. You did the best you could in the context you're in. Learn from your mistakes, but don't dwell on them. All right. Older solutions. This is fun. Developers, myself included, tend to say that Objective-C is old and busted. I've actually given several talks where I've used the words, and I quote, "Objective-C is broken and beyond hope." It's kind of mean. So yeah, Objective-C is old, but it's not busted. I mean, it's not broken. Objective-C is a technology. It can't really be broken. Older technology has advantages. Old is also stable. Old is probably well documented, and you can probably find developers who are familiar with that technology more easily than you can find developers who are familiar with the latest tech. I can find an Objective-C expert way easier than I can find a Swift expert. And old technology has a lot of resources available. It's easy to learn and it's easy to teach others because there are countless tutorials and resources, open source projects that you can use as an example, all kinds of things that exist for older technology that don't yet exist for Swift, for example. AF networking uses NS operation because NS operation is awesome. They needed something to do asynchronous programming, and they chose NS operation over blocks because you might want to cancel a network request, and blocks can't be canceled. Let's look at another example, NSURL session. I said we were going to come back to this. It has 4 different delegate protocols, which when I first saw that, I was, why do we need so many different protocols? This doesn't make any sense. It has a protocol for the session itself, and then the task, the data that it receives from the response, and the progress of the download. These are all different protocols. Why? Well, they separate the different areas of concern into separate delegate protocols. An object could conform to all 4 of them, or 4 objects could conform to each one individually. More importantly, 3 objects could conform to them, and 1 can be left out. If you don't care about the progress of your download, but you only care about the data you're receiving, then you don't need to implement the progress delegate. That's pretty cool. You can pick and choose the areas of concern that you're interested in and only implement the logic for those. Yes, you can do this with iOS, with protocols in Objective-C at least. Swift protocols don't support optional functions. You can't specify a Swift-only protocol that might have a function in it. The compiler won't let you. That's really interesting. Many small protocols are better than one massive one. I originally wrote this slide, and I said that NSURL session was very Swifty, even though it came out a year before Swift. And 2 developers I sent this to corrected me. And they said that when they did OS X programming, many different protocols are very common. And when iOS and UIKit came out, they departed from that. And we have UI table view delegate, which has it is only optional methods. And there's 20 of them or something ridiculous. That is a departure from what we used to do in Cocoa. We used to have many different protocols for the specific things we needed. And then UIKit combined them all together, and that's why we have massive view controllers. It's not Swifty, it's just a good idea, and Swift happens to do it as well. So, NSURL session could have been block-based, but they chose not to. I'm pretty sure that it wraps NSURL session under the hood, but we don't know because iOS is still closed source. So instead of building something on blocks, they chose an appropriate abstraction, NS operation, and they built on top of the ideas that NS operation provides, and it is not a leaky abstraction. This is really good. So what is a leaky abstraction? A leaky abstraction is, well, you need to know it's bad, first of all. You don't want leaky abstractions. It's like a leaky pipe. There's just no instance where a leaky pipe is a good thing. An abstraction is leaky if it exposes the underlying details of its implementation. So the reason that NSURL session is not a leaky abstraction is because we don't know how it works. If we knew that NSURL session used blocks or threads or NSThread or NS operation, if we knew that, would that help us if we didn't use that information directly? No. A leaky abstraction is a bad thing. You want tight abstractions that you only work at this level and you don't have to go down here. You want to stay up here. Yeah. So try to be more like NSURL session. You want to build purpose-built specific APIs that build on top of the existing well-defined behavior of existing APIs. No leaky abstractions. And I really, really encourage you to go read the NS operation header file. I bet that you'll find something really cool in there that you didn't know you could do, and then you'll be as excited to use them as I am. So let's wrap up. We talked about a lot of things. We talked about how decisions are made in an unknowable context. It's something that you can know at the time, but you can't recall later. You can't understand the complete context that any decision was made in. We talked about feelings and how you should, be less hard on yourself. Developers are bad at evaluating things because we conflate different ideas. 2 different disparate things happen and we think that they're related. We think that because there's an earthquake, we shouldn't use NS operation. New and shiny things are not always better. Sometimes they're better in a lot of cases, but there are very few cases where something that's new is always a good idea. And old solutions carry extrinsic benefits, things that make them good that have nothing to do with the solution themselves. They're easy to hire for, they're stable, they're well documented, there are many resources to choose from. So you may have come into this talk not really knowing what it was going to be about, asynchronous programming. What is that? You were probably hoping for a definite answer of the best way to do asynchronous programming. The question is, what is the best way to do asynchronous programming in iOS? The answer is it depends. Thank you very much. I think we have lots of time for questions.
Yes, and for 2 questions that were the best in your opinion, you can win 2 books: Clean Code and How to Be a Better Programmist.
Cool. Questions. It's really hard to see. Yeah.
Hello. I have a question about you told old I miss a word.
Take your time.
So, okay, solutions. All solutions then better than youngest in about like Objective-C and Swift. And what's happened when Swift will be in use like Objective-C? So we have frameworks, betas, and tutorials, and something like that. What's happened with Objective-C now?
That's a really good question. I don't think that Swift is necessarily always better than Objective-C, but it's good in the general case. I think that it's a better solution for most iOS developers. But right now, Objective-C still has the advantages that you referred to. Eventually, we'll get there. In a few years, Swift may be as popular as Objective-C. There are going to be books written in Swift, tutorials, open source projects. At that point, the context will change, and your decision of whether to use Objective-C or Swift is going to depend on that context. So it will be up to each individual, but I'm excited that we can switch to Swift and still acknowledge that Objective-C makes sense sometimes. Does that answer your question? Sure. Question here in the front, or wherever.
Hi, thank you for a nice speech.
Thank you.
You mentioned that we should use new APIs, new SDKs, new features. What are released by some companies like Apple. But in my opinion, I think we shouldn't use all new things because, for example, as you mentioned, NSURL session wraps NS operation. But if you wrap something, you have more code, right? So your code is working, needs to more time to be executed. In my opinion, we should go deeper, right? We should use as simple asynchronized methods to use it, because I think most developers should take care of the user experience, which is the most important thing in mobile apps.
Sure.
So we should use as simple methods as we can. Even if they are harder to understand or write or learn, we should use something what is really, really simple and just works really, really fast.
So there's a lot in there. I absolutely agree that the user experience is the most important part of an iOS app. You say that we should use the most simple solution, but that's not necessarily the fastest or the most low level. I mean, the simplest solution, in my opinion, is to work at a higher level of abstraction so you don't have to think about what's going on underneath. Your time spent as a software developer is very expensive compared to a few cycles on the CPU. Hardware is getting faster, but humans aren't able to understand more. I mean, there's no Moore's law for brains. As computers get faster and faster, we're going to, I think software is going to move more towards higher levels of abstraction that are simple, like you say, but also the speed difference is going to become, less important. Now, that's not to say that every case you should be using a high level of abstraction. The point of my presentation is really that different decisions make sense in different contexts. So sometimes it's going to make sense to use blocks or C sockets or POSIX threads. I mean, you can do all that stuff on iOS, and sometimes I agree it makes sense.
Maybe a good idea will be just divide some work for some special devices, like for example, iPhone 6 Plus, which is really fast, and make something different solution for example, iPhone 4, which is old phone, but many users has already this phone. So maybe we should just make make a code and write a code in two different ways for some specific devices.
Sure, and I actually know some developers who have done something like that. Because the iPhone 4 only has one core, concurrency doesn't really matter. In fact, it makes it slower because now you have competing things on the same core. So what they've done is they've built an abstraction on top of Grand Central Dispatch that checks if the device it's running on is an iPhone 4, then it does this thing, and if it's on something else, then it does the concurrent thing. So that idea of being aware of your different solutions and building on top of that is a great idea.
Okay, so the last question, because you mentioned on the start of your presentation that you'll be talking about the future. So do you have any idea or maybe some things what Apple or other developers can do in the future to improve asynchronous operations?
It's a really good question. I mean, there are lots of different languages and frameworks that are doing lots of different things. And my point really is that none of them are necessarily better than the others. .NET and C# have this really cool async thing that, one keyword makes your function asynchronous. And that's really impressive to me. I'm sure that there are really interesting things in Android. I know that there are interesting things in other languages too. And I think that really we should just learn more, try things even if they don't work, even if we know they're a bad idea, try them anyway because you'll learn something.
Okay.
Does that make sense? I don't have an idea of where we're necessarily going, but I'm really excited by the fact that we're going many different places. Not all of the different ideas that we're trying are going to work, but we need to try them in order to figure out which ones do work.
Okay, thank you very much.
Thank you. I think there are some over. Uh-oh.
Hey Ash, awesome talk, thank you.
Thank you.
Since you skipped over NS Progress, I looked it up quickly while you were talking. And Ole Begeman has a really good post about it.
Oh, nice. Of course he does, of course.
Yeah, of course. So it looks like NS Progress is a class that does a sinful mix-up between NS Notification Center and just a simple progress model. So it sends out notifications that carry on a simple object that has progress. Is it pausable? Is it cancelable? And so forth and so forth. Yeah, somebody was tripping on acid. They just decided to put it in the latest iOS.
Yeah. Well, when I first saw it, it was like an iOS 7 beta, and it was only used by this one function in NSURL session, and but now it's used in like a few different other places. I actually looked it up too. Like I didn't be like,
Gotcha.
I'm gonna put it on the slide. I'm not gonna know what it is because then someone's gonna ask me a question about it. It's useful, but it's really confusing. It's like
It's useful in a confusing way.
Yeah, I mean, why call it NS Progress? Like, that's such a broad thing.
Okay, thank you. Junior?
Thank you.
Hi, Ashna. Very nice talk.
Thank
you. You actually mentioned the patterns that were before iPhone for Mac developers, and then iPhone came, and some of them actually disappeared or changed. Is there a possibility that Swift being released on Linux, we can actually embrace some stuff that actually Linux people are doing?
That sounds
so
awesome.
can this actually release of the Swift standard library on Linux can have an influence as well on us as Mac and iOS developers from the Linux community?
I really hope so. I mean, that would be ideal. Open source is not just, let me rephrase that. you can do open source in a two-way communication style. In the past, Apple has released parts of the operating system open source, but they put it in a zip file and throw it up on a web page somewhere that no one can find. The idea is, or my hope is, with Swift, we're going to see maybe even a GitHub repository where we can open issues or submit pull requests. And if that happens, then that's amazing, because then we can invite Linux developers in, and then we can go and learn the patterns on Linux and bring those ideas back. That would be an ideal situation, I think.
Thank you.
I have a question. Have you make memory testing, performance testing, and energy testing for different technologies on the same task on different usage, and which one is better, which one is worse, or they are almost the same?
So I've done a couple of those, mainly the performance one, mainly on things like reactive Cocoa versus like GCD or something like that. The only real performance difference I've really noticed is when you're dealing with like disk operation and specifically core data, because who knows how that works. I don't think that, I mean, it's a balance, right? You can spend more of your time to have a faster program, or you can spend less of your time to have a program that might run faster. Now the question is, how big is that difference? Because if it's noticeable by a user, then as our friend earlier asked, then it's something you need to be aware of. But I think most of the time on current iOS devices, the 4S and higher, the difference is not going to be very big. I think that like the overwhelming majority of the time you should go with the highest level of abstraction and then test. And not like performance test, but like put it on an old device. You know, at the RC office, we keep some iPhone 4Ss around just so we can put the app on there on an iPad 2 or say, and just see if it's slow. If it feels slow, then we performance test, because otherwise we're just, you know, testing for no reason. Does that answer your question?
Yes, almost. But I want to mention that for phones, still actual the energy using. We have such problem with LS phones on Windows Mobile 6. That phone, after installing our application, can't work more than 12 hours. But it leaves about 3-4 days without application. So we need to solve this.
That's a really good point. I hadn't considered that. Yeah, so energy testing is definitely something you should do.
Because latest Xcodes already shows the energy uses as well. So
Right. Yeah, it's already in the debug pane. So yeah,
this is a good point to test as well. Thank you.
it is a good point. It's your point.
Hey, so thank you for the talk.
Thanks.
So you said about the fact that iOS is a junior community, which I think is true because it's very new. But which communities do you think we can learn the most from? Like maybe the Ruby community also went through these kind of phases, and Java's now been around for a long time, and Scala and a lot of other new ones. So.
Yeah, I mean, there are many communities. I like the parallel you drew to the Ruby community, because they have gone through so many problems like 5 or so years ago that we're facing now. So right now it's CocoaPods versus Carthage, and 5 years ago it was like Bundler versus Gemsets, I think it was called, and like Bundler kind of won. And it's not just in terms of tools, it's also in terms of like practices and like ideas. And like Ruby is like, oh yeah, let's unit test, this is great. And now we're like, maybe unit testing, good idea. So in terms of other communities, to be honest, I'm shamefully ill-equipped to answer that question. You know, I've only done production code outside of iOS. I've only been employed to write C, which is terrible, and C#, which is amazing. So I should probably play around with Python for a weekend or something. Do you have any suggestions on communities we should look at?
Well, I mean, I think the Java community is pretty good on that because they've done quite a lot of like publishing large enterprise systems and things. But I don't know as well. Like, there's lots of different communities.
If anyone has any suggestions, you should tweet at me.
The other thing is, do you think there's anything particular in a language or a community which enables it to like go a bit more crazy than others? Or like, I mean, Ruby is a good example for that, where people, I feel like they could build anything, so they sort of did. And
Yeah.
it was a bit mental, but
Yeah, I agree.
whereas Java's been a bit slower, right? So do you think maybe that's the language thing, or?
I think so. I mean, like, it comes from the direction, right? Like, so on the one spectrum, one end of the spectrum, you have Java, which is like designed by a committee of committees of committees, and then over here you've got like Ruby, where there's this one sort of charismatic guy who's leading the charge, but it's also this organized chaos of open source contributors doing whatever they like. I think Swift kind of falls like not like maybe 3/4 to the way there, because we have this charismatic company, Apple, who are like leading the charge, and like Chris Latner and his team are doing amazing things to move Swift forward. But with the open source announcement at WWDC, I'm really excited because I would love to have the organized complexity that Ruby has, maybe a little more organized for Swift. Yeah.
Thank you.
So I think you touched on a very important point that we often miss, which is the social aspect of being a developer. And you mentioned being empathetic. And I think like we keep on forgetting, like we as the developer community, we're very angry when we see a code that is, well, not the best,
I
right?
agree.
We're very vocal about it. And what you said is try to understand what these guys, what kind of situations they were in. So I kind of wonder, what's your recipe? What's your ways of not going, like balancing the ignorance and the need to level up others? Like, how do you stay sane?
That's a really good question. So I'm fortunate enough that I can work on some of these open source and community-based things as part of my day job at Artsy. So I'm very fortunate in that regard, that I don't just have to do this on the evenings and weekends, but I do it on the evenings and weekends as well. And it's a really interesting point of like how to balance that. So I made a networking library about a year ago called Moya. It became fairly popular in the Swift community, and maintaining it has taken up a lot of my time. So I saw this talk by a guy named Justin Searles. It's called The Social Coding Contract. I definitely recommend it because he talks about this. And one of the things he says is that a maintainer of a project is not a rock star. They're just a person who's doing something, and it's really easy for that person to become burnt out. And he has some specific suggestions around how to do this. So I followed them earlier last month, or 2 months ago. Geez, it's October. 2 months ago, there was an issue on Moya that was kind of contentious. Things had the potential to get a little heated. And I said, why don't we have a Skype call? You know, why don't we talk to each other face to face? I don't need to understand your contacts necessarily. I just need to remember that you're a person. And it worked because afterward, you know, we both realized that we just wanted what's best for, you know, the project and the community. We just had different opinions on what that meant. And it was amazing. The other thing I do is anytime I merge a pull request someone has submitted, I immediately give them write access to the repository. So they become a collaborator, they can merge other pull requests, and they can close issues or file them or whatever. This has helped a lot for a couple of reasons. First, it gives people a sense of ownership. Now I don't have to do as much work because they're excited to do it. So I don't have to, you know, I don't go crazy because I'm working on this project, you know, 12 hours a day. But in addition to that, so it reduces my workload, and it encourages them to submit other pull requests. And the thing is, there's hardly any downside to this. It's possible that now that someone has write access that they could, you know, force push to master and everything's gone. But like, that's undoable. Like there's Git history that we can recover from. So the danger there isn't that grave. So I'd recommend the talk. That's how I do it. I mean, like, most of the time, I guess what I'm trying to say is that you should just give people the benefit of the doubt. I wrote a blog post a few months ago discussing positivity and how, you know, if you're discussing something with someone over text, which is a terrible way to discuss things because it sucks the empathy out of the conversation, use emojis, use smiley faces, use exclamation points to indicate that you're excited about something and that, you know, you're coming from a place of passion and you're doing this because you love it. If you do that and you convey your emotions, then people are going to respond in kind, and that's a really great way just to, like, you know, avoid having hurt feelings altogether. Does that answer your question?
Yeah, that's really cool. Sounds like a lot of trust in GIFs.
Yeah, GIFs are GIFs are amazing. My colleague Orta has a free Mac app called GIFs. You should go download it. It's completely open source, so if you have a feature or something, you can just go add it, and he'll credit you in the App Store release notes. You can even, this is the most amazing thing. So everyone go download this app, find a GIF that you like, and there's a button in there. It says send to Orta, and he has a Twitter bot that just tweets at him the GIF that you selected. GIFs, amazing. Emojis, great.
Nice, thank you.
Cool.
Okay, two more.
So in your talk, you mentioned the term old technology several times, and I was wondering, is that synonymous with Apple technology? Because they are driving the platform, and I see all these open source projects pop up that supposedly fix shortcomings of that. And it's sort of my fear that if people only use this great open source project, they don't know what's going on, and then Apple takes a different turn, and you have to learn it again, or put it differently. Wouldn't it be better for people to first understand what Apple is offering before hopping onto a new shiny bandwagon?
That's a great question. So that gets to the idea of balancing using open source software with understanding the underlying technology, and that's something that every developer has to answer for themselves. Nick Arnott talked a lot about this, and his suggestion was that if you've never built something before, build it yourself, or at least read the source code for an open source project. But if you've done it before, just use an open source library because you understand already how it works. And I really like your point about the not understanding the underlying abstraction and maybe not doing something the best way. So for example, I discussed the UI gesture recognizer blocks libraries. Everyone made one. I made one. Everyone did. But the fact is, if you do that in view did load, now your view did load method is longer. Now your view controller might be shorter, but you're doing all the code in one spot. Maybe it would have made more sense to use the target action pattern that Apple provided for UI gesture recognizer, but put the code in a separate object. Now that you can test it, now you can keep your view controller shorter. I mean, we can't do that with blocks. We're not encouraged to. So there's definitely value in like thinking about the original way of doing something. And it's not just Apple technology. I think this applies to anybody. I mean, I tried to keep the technical conversation to a minimum so that hopefully this will apply to other communities as well, and hopefully they can get something out of the talk. Yeah. I don't know if there's another question.
I think it's the best one.
Hi, I have a little bit more technical question, I think.
Where are you? Sorry.
Here.
Oh, hello.
Hello. So how do you react to lock and unlocks in the code? Because we have all the atomic properties. However, lately I'm meeting quite a lot of this kind of direct lock directives in the code, and rarely I find a good reason to use them. So do you think that's a good choice in general because probably there are some specific contexts where you can use it, but in most cases I think that the atomic totally is enough for it.
Yeah, I mean, I want to make sure I understand your question. So the question is whether or not to use like atomic properties, or is it about the logging specifically?
Well, are there places in the iOS where the locking mechanism without using the atomic properties
Gotcha.
is?
Yeah, so that's a really great question. Atomic properties are deceptively like complicated because they suggest their name atomic suggests that they do something more than what they actually do. So NSLock is a really great way to lock code. There's the @synchronized as well. There are some places where you have to do that, but there are other solutions like using dispatch sync or dispatch async. So creating a singleton is something that you only want to do once, right? If you use dispatch once, that's a really great way to do that. That's a better way to do it than NSLock or @synchronized. So I mean, sometimes it makes sense and sometimes it doesn't. It's really going to depend on each individual situation. Does that answer your question?
Yes, moreover, thank you.
Okay, great.
Okay, so thank you.